Good afternoon, people. How are you guys doing? Good afternoon, people. Alright, cool. So that works. Alright, so thank you everybody for coming to the live stream. Today we'll solve our second exam for my Calculus 2 class. And the file is in the description. You guys can of course go download that and work them out along the way, or maybe if you have tried the questions beforehand, that's even better. All right. Well, if you guys don't know already, today we have Kirby right here, right? Special guest, special shout out, and also special shout out to everybody who comes, who's here today, and we are going to get started soon. Let me just make sure that everything's all right. I think so. Can you guys hear me okay? You guys should be all right. And let me just adjust the camera just a little bit if you guys don't mind. All right. I just want to adjust the camera a little bit. All right, so it looks like we have a full class right now. Yeah, 31 people. All right, here we go. Improper integrals. Right, for the first question. The first six questions are multiple choice questions, and here's the first one. Given that we have the improper integral going from 1 to infinity of this diverges, and we know that the function is positive for x is greater than or equal to 1, which of the following also diverges? So we have these options. Go ahead and leave your answer in the chat so that way I know. So again, we know that this right here diverges, and now the question is which of this also diverges? So how would you do this? In fact, when you guys are thinking, right, I will let you tell you guys a story. Before I give you out this test, I actually gave a little gift to my Calculus 2 students. I actually told them about the answer to the first question for this one, just to give them a little gift for the people who were actually paying attention and for the people who were actually still being in the class and all that stuff, because I'm teaching online. So that's that. So for the people who were there and if they were still paying attention, because I just do this randomly and they would know the answer, which how I'm doing. But this one is actually not bad to do solve on your own too. So which one do you guys have? Anybody? All right, so I'm going to wait for another 10 seconds or so. If you guys know the answers, if you guys know the answer, then just go ahead and leave it in the chat so that way I know. So which of this also diverges? For the multiple choice question, I'll give you guys some time to think about before I tell you guys the answers. All right, so okay, cool. A lot of you guys are saying B. That's indeed correct. B is the answer for this. And here is the deal. Because we know this right here diverges, what we want to show is we hope that the integrals right here is greater than or equal to the one that we know. So we just have to check this inequality. And this is the idea from the comparison test. So we just really have to check that. So let's see. Let me just put all this down right here. And once you see all these inequalities, then you guys will see that YB is correct. So 1 to infinity, f of x, dx, and of course, lastly, integral going from 1 to infinity, f of x, dx. All right, so as you can see, B is of course correct because this has f of x and then this right here plus 1, so this is definitely correct. So this right here is the answer for it. A is not true, right? Because let's talk about some counter example. So I'm just going to put this down right here, counter example. Well, if you have f of x is equal to 1, somebody also mentioned that as well. Fountain, yes. Yeah, if you have f of x is equal to 1, then you can see that, yes, we know this right here diverges. Integral going from 1 to infinity of 1 dx. This right here goes to infinity, which diverges. And if you put 1 in here, this is integral going from 1 to infinity, 1 minus 1. And you really have to do this right here first. So you really just end up with the integral from 1 to infinity of 0. And this right here is actually just 0. So it is trivially converges to 0, yeah. So A is not the answer. And for C, anybody would like to give a counter example for C? 1 over x, perfect. So a counter example for this right here is, let me just write this down. F of x, you can just take it to be 1 over x. Well, the integral going from 1 to infinity of 1 over x diverges. And if you square that, it becomes 1 over x squared. That one actually converges. Yeah. How about D? Yeah, okay. How about D? How about D? Anybody would like to give a counter example for D when we take the square root? Even though, of course, this is not necessarily true, but let's have a counter example so we can see better. What do you guys think? Give an example so that the integral going from 1 to infinity of f of x diverges, but if you have the square root of f of x, that actually converges. So how can you get an example for that? Alright, 1 over x also works for E. That is correct. So if you also look at this right here, if we have f of x equals 1 over x, this right here diverges, and if you divide it by that, then that also diverges. So yeah. How about D? You know, all of a sudden I don't have an example in mind. I don't know why. Let me see. We want that to be diverge, and then I think this one will work. F of x equals 1 over x. And if you attach ln x, no, that will still not work. I think this actually, yeah, I'm actually not going to do this because I do not know. I think this, I think, I don't know why I'm all of a sudden cannot think about a counter example right here. When I was coming up with this, I thought I have an example for that, but like I can't think about one. I think because since I have this condition, so that makes it much harder for me to come up with a condition. I mean, because I have this condition here, so it makes me much harder to come up with a counter example. So if you have 1 over x, right, that converges. But if you take the square root of, sorry, if you have 1 over x right here, that diverges. If you have square root of 1 over x, right, that still also diverges. So that's not correct. I was thinking about you should have like some negative parts inside, but because I have this condition, I forgot about that. So I will think about it. Yeah, but for my class, if I choose B, that will be correct. That's all. And yeah. Alright, so maybe you guys can think about it, but oh man, this condition is a little bit too strong for that statement. I think Dr. Pan will actually prove that this is actually true. So let me just erase this right away so that nobody sees it. Because sometimes, like, once you do a question, once you start like talk about the question, you realize, oh shoot, there's some small details that, didn't think about that. But like, yeah. Yeah, so if you guys know the answer, just leave a comment later on. So, all right, okay, continue. So, for number 2, we'll just do a really straightforward computation. So we have an integral going from 1 to 4, and then we have 4 to the sine x power. It's impossible for you guys to actually integrate this, but we want t4. Sorry, we want t3, meaning that we want to use the trapezoidal rule when n is equal to 3. So that's what t3 stands for. And this is what I like to tell my students to do. First off, compute the delta x. So delta x is just going to be, you do 4 minus 1, and then divided by the n, which is 3. Because this right here means n is equal to 3. And then, of course, delta x is just equal to 1. And then you don't have to graph the 4 to the sine x power. All you have to do is just draw a number line, and then we are going from 1 to 4, and then you just make 2 cuts. And you know each piece is going to be 1 unit width, right? So these are the x values that we are going to use. And of course, we have the function is just 4 to the sine x power. And t4 is just, t3 is just going to be the following. This right here is equal to delta x divided by 2. Delta x is 1, so we have 1 over 2. And then this is the first x value we are going to plug in into the function. So we'll just have f of 1. And then the next one, it has the coefficient 2. So you just multiply 2 with f of the next x value, which is 2. And then you're just going to add 3 times f of the next one. Sorry, not 3 here. 2 here, and then 3 here. And then lastly, this is the last x value that we are going to use. So the coefficient for that is just 1. So you just have f of 4. So that's that, and then just plugging everything into the calculator and then work that out, you'll get approximately 6.524. And that will be the answer, and that will be answer choice A. That's it. Right? So if you are here, if you're taking Cal 2, let me know if you guys are also doing this or not. Or you can also let me know what class you are taking. So welcome to Just Calculus. This channel is all about calculus, and of course sometimes pre-calculus as well, because you know the deal. In calculus, it's not really the calculus that gets the student. It's the algebra and also the trig, right? Which is pretty much the things that you guys do in pre-calc. Alright, so if you're taking calculus, let me know. You're in Calc 1, nice. Right. Ingredients, that's correct. Yeah. On the actual test, I actually gave the picture, so it was more clear. But like, if you look at the file, I just took out the picture so that the file is more compact. Otherwise, the test is like 11 pages. All right. Now, next, we are going to work out a differential equation. But for our class, we did not go over how to solve a linear differential equation. So this is what we are going to do. So we are given that we have a differential equation, dy dx is equal to y plus sine x, and then we also know that we have the initial condition y of 0 is equal to 1. You just have to pick up the correct answer from the answer choices. So we have a couple of them. The first one is that y is equal to sine x plus cosine x. And then the next one is y equals, you have 3 over 2 e to the x, and then minus 1/2 sine x, and then minus 1/2 cosine x. And then next one, we have y is equal to e to the x plus sine of 2x. And then the last one. So for this one, I just gave out 4 choices because the way to do it is you just kind of have to plug in and check. so you can understand the structure of the differential equation. So that's that. 3 over 2x and then minus 1 over 2 cosine x, and lastly put a plus 1. All right, so take a look and let me know if you guys have any suggestion. Which one do you think is the answer? You do not have to solve this from scratch because this is a multiple choice question. It's meant to be that you pick a answer choice and differentiate it and then plug back in to see if it works out or not. And then we do have to finish this within an hour or so. Right now it's 2:17, but I have a class at 3:30, so we're gonna do it fast. Unfortunately, it's not C. It's actually not C. Even though if you put 0 in here and here, you do get y of 0 is equal to 1. The initial condition right here does work for C. It does work. But this right here will not satisfy the differential equation, so it's not C. Yeah, you can just real quick and do the derivative. This is e to the x, and then you get plus 2 cosine of 2x. And if you put this here, then you see that you have the cosine, but on the right hand side you do not have the cosine. So that's one way to see it. So it's not C. It's also not D. Let's see, if you plug in 0 into all the x's, you can see that this right here tells you y of 0 equals, this is 1, so you have 3 over 2. And then this is minus 1/2, right? Plugging 0 here. And then lastly, you have the plus 1. So this is actually 1 plus 1, which is 2. So you see that this right here does not satisfy the initial condition. But with that being said, this right here is also not correct. Because we want to have y of 0 is equal to 1. This is y of 0 is equal to 2. So unfortunately. All right, so we knocked out 2 of them. Now it's 50-50. All right, quick. All right, so Nathan, you said it's A first. Let's see. If you plug in 0, it does check, all right? And then let's just go ahead and differentiate that y prime is going to be the derivative. This is cosine x, but the derivative this is negative sine x. If you put this on the left-hand side, if you put this on the right-hand side, you see sine x plus sine x, we get 2 sine x. So A is also not correct. So with that being said, you know B is correct. I do have a small tendency, I don't know why, to put the correct answer to be answer choice B. So for my students or for my future students or current students or whatever, yeah, but I don't know. This right here is actually correct. So let me just go ahead and verify that for you guys real quick. So if you look at that, you see that y prime is going to be the derivative of that, which is 3 over 2 e to the x. And then this right here gives us negative 1/2 cosine x. And then this right here gives us positive, right? Positive 1/2 sine x. And if you put this to the left, which let me just put it down right here, is this equal to the y, which is 3 over 2 e to the x minus 1/2 sine x minus 1 over 2 cosine x. And then we have this sine x. So if you added that sine x right here, you see this and that together gives you positive 1/2 sine x. So this right here indeed correct because it satisfies the differential equation. But also, if you put 0 into here, here, and here, you will end up with y of 0 equals 3 over 2. That will be 0, and then you just have to minus 1/2. So this is also going to be 1. So B is indeed the correct answer. So that is that. Cool. Okay, so that's that. Okay. And by the way, I think this is what we got last time. Remember last time, if you were here last time, I told you guys you cannot say U sub in the chat, and then I think we found out why. Because if you say U sub, right, which stands for U substitution for calculus, of course. But one of the viewers pointed out that if you put U sub, it sounds like sub for sub. It's like you sub to me, you subscribe to me, and I subscribe you back, which is not allowed on YouTube. That's why I think that's the reason why that U sub was not allowed. So just for your information. Okay, I did this question on a video already, but let's go ahead and do this together. Which of the following is equal to 1? I also explained my thought process of coming up with this question, but let's go ahead and do it. Here we have the limit as x approaching infinity, ln of x plus 1 over x. And then, so x plus 1 over ln x. Next, the limit as x approaching infinity, ln x over x plus 1. C, the limit as x approaching infinity. And then we have ln of x plus 1 over ln x. And then we have d, which is the limit as x approaching infinity. And we have 1 natural log and then x over x plus 1 inside. And lastly, e is just none of the above. So with this option, that makes this question, automatically harder. So which one is it? Which one was it? Which of this limit gives you 1? And in fact, I'm making you guys do 4 limits instead of just 1. So this is one reason why that I love multiple choice questions. Alright, the correct answer is not E. It's C. And the quick way to do this is that if you have x is approaching infinity, you can ignore the plus 1, so you pretty much just have ln x over ln x, which that gives you 1. That's the quick way to do it. It's not too much, well, it's okay, I'll say it's not like too legitimate, but of course, the correct way to do it is you do L'Hopital's rule and you get the limit as x approaching infinity, and you get 1 over x plus 1 over 1 over x. And this is just going to be the limit as x approaching infinity. Flip that, so you get x over x plus 1. And you can do L'Hopital's rule again, or seriously just ignore 1. Or you can do it the pre-calculus way, but seriously, right here should be okay to see that it's just equal to 1, and then we are done. The answer for this is that it's infinity. Why? Because on the top we have x to a first power, on the bottom is natural log of x. So this right here is going to be eventually much bigger than that. And if you have the other direction, this right here will be 0, the reciprocal. This right here, you do this inside out. Inside x over x plus 1, you get 1. But you have ln of that, so the answer for that is 0. So you have infinity, 0, 1, and 0. So C is the answer for that. That's all. Yeah. So you see that they all look similar. They all have the ln, and then they have the x and also the x plus 1. And it's all x approaching infinity. And that's one of the things that I like about having like a nice multiple choice question. All right. Number 5, we're going to do a Simpsons rule question. So given that we have the integral which is impossible to integrate, we have 1 to 3, and then we have 1 over 1 plus ln x dx. And then we want to have Simpsons rule, right? When n is equal to 4. So we're going to do what we did earlier. Let's go ahead and just compute the delta x, which is just this minus that and divided by 4. So we have 3 minus 1 and divided by 4, and that will give us 0.5. And you don't really have to graph this function, but rather you just have to draw a number line so you can see what x values that you are going to use. So I'm going to just say we are going to go from 1 to 3, and then we are going to make it into 4 pieces like this. Each piece, the width is 0.5. So of course this is 1.5, and then 2, and then 2.5, and then 3. So these are the x values that we are going to use. And of course, the function that we are talking about is 1 over 1 plus ln x. And now you can just apply the formula. Here we go. S4 is equal to delta x divided by 3. So here you have 0.5 divided by 3. So that's the Simpsons rule. And now, the first x value, when you plug in, the coefficient for that is just 1. So we just have f of 1, like so. And then the next one has coefficient 4. So you put down 4 times the next x value, which is 1.5. And then just continue. But the next one has the coefficient 2. So you put down 2 times f of the next x value, which is 2. And then it's like 4, 2, 4, 2. It just kind of alternate. So the next one is going to be 4 times the next x value, which is 2.5. But we see that when x is equal to 3, that's the last x value. For the last x value, the coefficient for that is just 1. So you just have f of 3, like so. And enter all this on the calculator. The way I like to remember the Simpsons rule is that you divide the delta x by 3. And then the coefficients is 1s, like this, and then 4s, and then 2s, and all that. Yeah. So you see 1, and then 4, and then 2. Of course, usually I don't ask like S10 because that would be just too bizarre to compute. So 4 is a good number, or maybe sometimes 6. But yeah. Anyway, just work this out on the calculator. So straightforward computation, and you will get approximately 1.2652. And that's how you worked out a Simpsons rule question. You wish you used the number line tip. Oh, yeah. Because this is really what you need, because you don't really have to take a look at the graph of that, assuming the graph is nice, which it is, meaning continuous and differentiable. Well, continuous is the key. And yeah, that's all. That's all. Who does Calc 3 here? No, not me, unfortunately. I'm not doing Calc 3, I'm just doing Calc 2. And usually I teach Calc 2. Next semester I'll be teaching Calc 1. So you guys can expect a lot of Calc 1 material. And this semester I'm also teaching pre-calculus class. So yeah. And I will also be like organizing my old videos. I will move my old videos to this channel, especially the ones that I have never made them public before, because I do have a lot of videos for my students. You guys just have never seen that before. For the next one, I'm not going to write down the whole thing because I want to have enough time to work out the remaining questions. And for this, just go ahead and read the question. For number 6. Right, so you can pause, or maybe just go download the file. It's much easier. Yeah. Right? So it's like you have a room, and then the air is coming into the room. And the air contains 0.15% carbon dioxide initially, blah, 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 blah. But fresh air with 0.04% carbon dioxide comes in. So all you have to do is the following. The question is asking, what is the limit as t goes into infinity of a of t? What is a of t? A of t is the amount of the carbon dioxide in the room. Alright? A is the amount of carbon dioxide in the room. And you see, the limit as t goes to infinity, this means eventually how much carbon dioxide will you have in the room? Well, you can imagine that we have a, let me just still draw a house. Now this is like a room, right? So you have like fresh air coming in, and the volume of this room is 200 meter cube. And then you have fresh air coming in, and then the concentration for that is 0.04%. And in fact, that's all you have to know. This is indeed a calculus question because we're using limit, but if you just think about it, you do not have to solve any differential equations whatsoever. Well, you have the carbon dioxide coming into the room, and then of course they also have the things going out. The flow in rate and also the flow out rate are the same. You can read that from the question. And to answer this question, you know, eventually you just get all this, right, for the concentration. So all you have to do is just 0.04%, which is 0.0004. Yes, yeah, and then times 200. And that will be 0.08. That's it. And then meters cube, and then perhaps I'll write this down. Carbon dioxide of carbon dioxide. Alright, just for fun, anybody study chemistry? What's carbon dioxide? What's the formula for that? Is that related rate? It's not related rate. It's technically differential equations. It's kind of like related rate for this particular one. But remember, when we have a differential equation, it's about rate. So it's really similar to the related rate. But yeah, if you want to see how to solve the differential equation, I do have a video on this kind of things already. So you guys can go ahead and check that out. But anyway, yeah, this is very just carbon dioxide CO2. Yeah. But anyway, we have these questions that I want to get to, and hopefully I can finish all this in an hour with explanation. So that's why I don't really want to go into too much detail solving this right here for you guys. And maybe I can say hi to my future Calculus 2 students. If you guys are watching, hi. Maybe next semester or maybe after a year when you guys watch this to study for your Calculus 2 exam number 2. Okay, so number 7, this is a shorter question now. We are going to determine if the improper integral going from 1 to infinity of 1 over square root of x plus e to the x, does this converge or not? So let me just write that down right here. So just real quick in the chat, let me know, does this converge or not? Just real quick. Oh, hello, hi. You missed the old Tuesdays. Yeah. I don't do it on my main channel anymore because this channel is meant to be for all calculus. So I think it's more appropriate to have the live streams on this channel instead. So yeah. Let me know your name. I don't think I have ever got your name. So T-Sonic. Yeah, I'm talking to you. Yes, yeah. Anyway, does this converge or diverge? I'm sorry, I don't know how to pronounce the name, but yes, if you say converge, that is correct. This right here does converge. But we have to give a reason. We cannot integrate this, so we use the comparison test. And this is how I tell my students to do, especially for the first time students who take Cal 2. The 3 steps. First, we are going to write down what we know, so we can use that to compare with this. So here we go. We are going to just ignore the square root of x because you want to pick out the dominating part, which is e to the x. So ignore that. So just look at the integral of 1 over e to the x. So this right here will usually go really well if you do it like this. And you do so when you have the integral going from 1 to infinity. You picked out the dominating part. You can use the list that I have showed you guys before. But anyway, this is much easier to deal with. We can, of course, integrate that. So let's go ahead and do that. So this is the integral going from 1 to infinity. And we have e to the negative x dx. Integrating this right here stays. But you have to divide it by -1, right? So you have negative like that. And then you plug in. So the first term is negative e to the negative infinity. And then minus plugging 1. So you have negative e negative 1. Okay. Good news. This right here is 0. Negative is positive. And then we have e to the -1, which is 1 over e. So this right here does give us a finite result. Therefore, this right here converges. All right. And now we are going to do the check. And for the comparison test, this is technically called the direct comparison, meaning that we're just going to compare inequalities. We hope to show that this right here is smaller than or equal to this right here because we have a convergence situation. So let's go ahead and write that down. We hope to show that the integral going from 1 to infinity, 1 over square root of x plus e to the x dx. We really hope to show, but we don't know yet, smaller or equal to that 1 to infinity, 1 over e to the x dx. And you see, everything is positive, and then we go from 1 to infinity, so you know everything is positive, right? So we don't need to worry about this being negative infinity. No. And because both integrals go from 1 to infinity, just compare the inside. So we have 1 over square root of x plus e to the x. This right here is actually just really straightforward, but we just have to kind of write it down nicely. If you would like, because nobody likes fractions, you can cross multiply, and everybody is positive, so this right here becomes e to the x, and then this right here is just square root of x plus e to the x. Is this true or false? Definitely true, because x is greater than or equal to 1. So you have that being added. So this is clearly true, and congratulations. If we have a true inequality from here, then we can move to the final boss, or just like draw conclusion. And for the conclusion instead, we'll just restate that, right? Just write it down again. The integral going from 1 to infinity, 1 over square root of x plus e to the x. We will say this right here, let's use the word also. Also converge. Yeah, also converge. Yeah, by the comparison test. And we are done. So that's how you work out a comparison test question. Yeah. However, if you use the integral of 1 over square root of x, then in fact the whole thing is wrong, because not only you cannot draw conclusion, but you might be likely to draw the wrong conclusion. So yeah, let's have a look at that. Oh, hello, Tabua. Hello. What time is it over there? Like, let me know what time it is for you guys, because I see on my analytics, usually in the afternoon time, nobody is on my YouTube channel, because I figure a lot of people are from different countries, and right now it's 2:38 p.m. I do have a class in like an hour, so I would like to just try to finish this as soon as possible. And if you are my student, right, we have a class tonight. Just leave in the chat and let me know that you are from my Calculus 2 class. So this is the test that we took last Thursday, and then yeah. Okay, I did this one as a separate video already as well, but let's do them again if you haven't seen that. Let's go ahead and compute the integral going from the cube root of 2 to infinity of 1 over x times the square root of x to the third power minus 1 dx. I will tell you this right here does converge. Right? It does converge, but what shall we do? Alright, so let me know. Let me know what we should do. Oh, hey, the good place to stop. Hello. Now people are from everywhere. 11:38 p.m. I wonder where that is. Wow, so in the UK, a lot of people from UK, huh? Okay, so let me know what method shall we be doing. So I want to see how many of you guys answer that before we go. No, we are actually going to get the value out of this. So if you try to do comparison, that's not going to work, because I do say on my test, we are going to evaluate this, and we are going to give a exact value for it. Oh wow, 10:39 p.m. So I think still okay, not too late, right? But of course it's in the evening time. But anyway, what shall we do with this integral? What shall we do with this integral? Give you guys about 10 more seconds or so. Oh, Nicholas, good morning. 7 a.m. All right, good morning. All right, shall we do trig sum for this? Maybe not, because you have x to the third power minus 1. So the traditional trig sum, it's not going to work out too well, right? Because we want to have x squared minus 1. If that's the case, then we can do x is equal to secant theta, and then you continue from there. That might be okay. But this is x to the third power. So this is perhaps one of the good examples that if we don't know what to do, just go ahead and do a u sub. So we are going to let u equal, in fact, the whole square root part. So put down the square root, x to the third power minus 1, and hope for the best. It will be the best. Check this out. Differentiating both sides, we get du equals, the derivative of that is just 1 over 2 square root of that, And then you guys know it. What do we do now? Anybody want to say it? And by the way, yeah, you guys cannot really say use sub in the chat because YouTube doesn't like use sub if you guys were here during the last live stream. By the way, I'm going to let you guys say it. You guys cannot say use sub, but you guys can say the following. What do we do next to do the derivative? Not the chain rule. I don't know what the chain rule is. Oh, this is to honor Dr. Payam. We are going to use the chain rule, right? So you multiply by the derivative of the inside, which is 3x squared. By the way, I didn't come up with that. It's all Dr. Payam's fault. But anyway, so that's the chain rule part. And then you multiply the reciprocal, so you can get 2 square root of x to the third power minus 1 over 3x squared du. And now let's take this integral to the u world. And don't forget to take these numbers with u as well. Here we go. Put this in here. Cube root and cube cancel. 2 minus 1 is 1. In the square root, still 1. So in the u world, we go from 1. Put infinity to here. We also get infinity. So u goes from 1 to infinity. And then we have 1 over. This is just x. This is our u. And then dx is all that, which is 2. And notice, here, this is just our u. So I'm going to put that down right here. We have 2u on the top, and then divided by 3x squared du. And this works out so nicely because first you see that the u and u cancel. We do have the 2 over 3, like the constant multiple. So we can put it on the outside. And we'll finish everything in the u world, which is the best place, the happiest place for integrations. And here we have 1 over x to the third power though. How can we integrate 1 over x to the third power? Can we do this? Man, if you guys like put on u sub in the chat, then I will have to manually approve your chat because YouTube just doesn't like that. But anyway, can we integrate that? Can we write this as x to the negative 3 power and integrate that? No. And the reason is because we are in the u world. So do not look at x to the third power as x to the negative 3 and then integrate there. No. But instead, you are going to look at this right here, and then we are going to square both sides, right? So they cancel, and we can see x to the third power minus 1 is equal to u squared, and then we can add a 1 on both sides. So x to the third power equals u squared plus 1. And that will be for this guy. So as you can see, this right here will give us 2 over 3 integral going from 1 to infinity in the u world, 1 over u squared plus 1 in the u world, and then we integrate. So that will be a common mistake, like if you just integrate this as x to the negative 3 power. And then if you integrate that, you get inverse tangent. So we have 2/3 inverse tangent of u, and then just plug in numbers, right? So we have the 1 and also the infinity. So let's plug in infinity first. So we have 2/3 inverse tangent of infinity. So that's the first part. And then minus 2/3 inverse tangent of 1. All right. So now here's the deal. This right here is pi over 2. Right? Technically, you take the limit, right? And then it approaches pi over 2. Inverse tangent of 1 is pi over 4. So all in all, you see this times that, the 2's will cancel. So perhaps let me just cancel them for you guys like this. So we get pi over 3. And then minus, we can reduce this. So this is 1, this is 2. This times that is pi on the top over 6 on the bottom. And then right here, of course, we can just get the common denominator and then the good old business. 2 pi minus pi is just pi. And then the denominator is just 6. And then we are done. It ends up to be a very nice number, pi over 6. Cool, huh? Yeah, so just like that. Okay, so hopefully we are doing good in time, because as I said, I do have a class in like 40, 50 minutes. So yeah. And now we have a lot more people coming up. Yeah, thank you guys for coming. And if you guys missed the live stream earlier, then you can just go download the file, and later on, you guys can also watch the replay. But the file is in the description. Next one, this is the fun one. I love to ask students to give me examples. This is perhaps one of the best way to reinforce if the student understand the concept or not. So number 9 is about give an example. Right? Give an example. The first part, I want a convergent type 2. Wait, that's wrong spelling. Type 2 improper, let me just spell it out, improper integral. All right, so let's focus on this one right here first. Anybody would like to give me an example? And for type 2, this right here means that we have to have a vertical asymptote. So I'll just write this down for you guys. We have to have a vertical asymptote on the interval that we are integrating on the interval. Type 1 is where we have infinite interval. So maybe going from 1 to infinity and things like that. So can you guys just give me a convergent type 2 improper integral? It does not have to be too hard, right? It does not have to be too hard. All right, Carlos, that's the one that I demonstrated in class. So I'm going to write down your name for that example you gave. So this. All right, are we back? Hopefully that's. Are we back? Are we back? I'm glad that I caught this soon enough, because otherwise I will be talking and then like talking to nobody. Yeah, sorry for the little disconnection. Cool. All right, so let me just go over this real quick. We didn't miss too much. This improper integral is type 2 because it has a vertical asymptote, and it does converge if you do the integration by parts and then plugging the numbers and things like that. And technically, when you say 0, this right here is technically 0 plus when you take the limit and all that good stuff. And you end up with -1. Yeah. All right, I'll take another example. We want convergent. We want to have type 2, so we want to have a vertical asymptote. So the Google account, if you say 0 to infinity, that's actually both types, meaning we have an infinite interval and also a vertical asymptote. So that will not really be a type 2 situation. We just want type 2 situation. So anybody? Anybody? Tangent x, does that converge or does that diverge? I thought that diverges. If you have tangent x from 0 to pi over 2, that one should be diverge. Yeah, that one should be divergent. So you can use that for the second part, because part B, my question is, we want to have a divergent type 2 improper integral. So yeah, these are the questions for number 9. So let me see. Mohammed, I am going to put that down. I believe the tangent one is divergent. Yeah. So let me just write down your name. Let me make sure that I spelled it right. Right, and then you say it's integral going from 0 to pi over 2, and then we have the regular tangent of x like so, and this right here diverges, and this right here, let me just show you why, because we have a vertical asymptote at x equals pi over 2. Yeah, and then of course we should all know that the graph of tangent looks like this, somewhat like that. And then we are looking at this region, and this is technically infinity. Because if you integrate this, you get ln of secant x, right? And then if you plug in pi over 2, like a little bit less than pi over 2, like you take the limit, you actually get infinity of that, and then yeah, just actually infinity. So that one is that. Okay, and then let's see, window. That's such a great name. If you have the integral going from 0 to 1 and then 1 over x. So I'm going to write that down. So this is by window. I haven't used window for like at least over a decade. Window Vista. 2.0, it's not just 1.0. And example that you give is 0, technically 0 plus, and this is technically pi over 2 minus because you have to take the limit. 0 plus to 1, 1 over x dx. And this right here, you are talking about this one, right? You're talking about from here to here. Yeah, and this right here, it's also infinity. You can just integrate that, you get ln, and then that will just be infinity for that. So this would be an easy example for part B, and that's it. I didn't need to have like a hard example for that. And let me put out another example for part A though. If you have 1 over x squared from 0 to 1, that will also diverge. Yeah, if you have 1 over x squared here, that will also diverge because we are talking about the type 2 when we're talking about the vertical asymptote. So how about let's have another example for part A. So a type 2 improper integral that converges. And to my surprise, a lot of my students, because I just finished grading the test on Sunday, either they were trying to give like hard examples or they just didn't know what to do. We did this in class, in fact, this particular example. And we also have this question on the homework, I believe. And this one, we also talk about it in class. But they were trying to, yeah, overcomplicate their example, so that's not too good. But I will give you an example. I will give you guys an example. If you have the integral going from 0, technically 0 plus right here, and then you have 1 over square root of x dx. I'll do a computation for you guys real quick. Integrate 1 over square root of x, you get 2 square root of x, and you plug in 0 plus and 1, and you just get 2 square root of 1 minus 2 square root of 0 plus, or 0 doesn't really matter, and you just get 2. So of course, this right here converges. So that would be a very nice and sweet example. Yeah. Google Plus, that example I cannot do in my head, so I do not know. Yeah, but like, you don't need like complicated example because if you want to integrate 1 over e to the x minus 1, it's not too bad, but just try to give like an easy example, that will be enough. Yeah, I do not know that one though, so yeah, you guys can compute it and let me know. All right, so that's that, and then a couple more questions. So I'm going to turn into black pen, red pen fast because I only have about 30 minutes left. So yeah, if you guys are watching the replay later, I'll just kind of pause if you guys need to. All right, number 10. Compute two limits. So first part, we are going to get the limit as x approaching infinity of x over x plus 2 to the x power. So if you can do this in your head, go ahead and do that. Meanwhile, I'm going to put down b, which is the limit as x approaching 1 plus, and then we have ln of x minus 1 minus ln of x squared minus 1. All right, anybody has the answer for that? Now, I wish I can give you guys more time, but I do have another class in like 30 minutes or so. Immediate, that is correct. E to the negative 2. And Connor, that is correct. Yes. Yeah, so this right here is indeed equal to e to the negative 2. Cool. How about this one? Because for these two, you can actually do them rather quickly. So let's go and do them. Yeah, Miguel, that's correct. You got it right. E to the negative 2. How about this one? Am I lagging? I don't know. Yeah, but like I see a lot more people put down e to the negative 2 now. Yeah, so yeah, you guys did it right. How about this one? Not ln2. Close. Almost, but not ln2. Ln of 1/2, that's correct. So, Teddy, thank you. So I'm just going to put this down, ln of 1/2. Yeah, so that's that. Let me go over this real quick. You do not need to do L'Hopital's rule because if you have seen my video on the secret weapon, which my students should have, you can just use the secret weapon. And to do so, I'll tell you. I'm going to flip this. So first, we will have the limit as x approaching infinity. Look at this as x plus 2 over x. But you have to make sure you negate the exponents, so you have negative x. And the reason we want to do that is because now we can split the fraction. So this becomes the limit as x approaching infinity. X over x is just 1, and then we have 2 over x, and then we have the negative x right here. And as you can see, a is equal to 2, and then b is equal to negative 1 right here. So this right here is from the fact, right? That's why I call the secret weapon. And this right here is just equal to e to the ab, which is 2 times negative 1, which is just e to the negative 2. And if you want to be fancy a little bit, you can say 1 over e squared. That's definitely okay. Done deal. Now for this one, if you put 1 plus into all the x's, you will end up to have, let me see. You will end up with negative infinity and then plus infinity, which is actually indeterminate. So you are going to do some work for that. We can combine the natural log. So we will, this right here is the limit as x approaching 1 plus, and it becomes just ln of x minus 1 over x squared minus 1. And for this, you can do it whichever way that you prefer. Maybe L'Hopital's rule inside, or maybe just factor and cancel. We will do factor and cancel. Factor the bottom, we get x minus 1 times x plus 1, cancel this out, and then we can just plug in 1 in here. So you see this is just ln of 1 over 1 plus 1, which is just ln of 1/2. And in fact, this is a negative number. This is the same as negative ln2. So depends on however, if you answer the question like this, that's totally fine. So that's it. Cool. All right. By the way, if you think the questions are too easy, or if you are all done with Cal 2 already, try number 14. It's actually doable. Yeah, you don't have to do the third derivative, but try to do number 14. It's this right here. If it's easier for you guys to see, it's this one right here, number 14. But anyway, I'm going to do number 11 for you guys right now. So it says, given the rate of change of y with respect to t is inversely proportional to y squared. The rate of change of y is inversely proportional to y squared. So with that being said, we know the rate of change is the derivative, so we have dy dt, because we're talking about time. Dy dt, this right here is equal to inversely proportional, means that you have the constant of proportionality k, but you divide by y squared because it says so, right? Inversely proportional to y squared. So that's what it means. And we also know that y of 0 is 2, and then y of 2 is 10. And we would like to know, and this is how you should solve like a word problem. So always put down what you know, especially in the differential equation language, and then write down what you want to know. we want to know what is y of 4. So we can just solve this differential equation and then figure out the c and also the k, and then in the end just plug in 4, and that's it. So let's go ahead and do that. So we have dy dx, this is equal to k over y squared. We are going to multiply y squared on both sides, so we have y squared dy, and that's equal to k times dt, sorry, dt, so k dt, sorry, I got ahead of myself a little bit. And then from here, we'll just integrate both sides. The left-hand side, we get 1/3 y to the third power, and you don't need to worry about the plus c, just put it down on the right-hand side, and on the right-hand side, integrating this, we get kt plus c1. Now, multiply everybody by 3, so we get y to the third power, and then 3k has to stay the same, and then we have the t, and then c1 is a constant, 3 is a constant, 3 times a constant is just another constant, so we put on plus c2. Yeah, like that. And then, of course, if you want to get y by itself, we get y is equal to the cube root of all this, which is 3kt plus, and we're done, so we'll just label this as c. Yeah. And because we're all done, I would like to write this down as y as a function of t is equal to this. All right, now we know we have y of 0 is equal to 2. So we can just put down the 0 into this t right here, and we get the cube root of 3k times 0 plus c. That's just 0. And then we get 2 is equal to the cube root of c. So c is equal to 8 after you cube both sides. And from this equation, we know y of 2 is equal to 10. And that will tell us the cube root of 3k, and then the t is 2. But we know c is equal to 8, so just put on plus 8. Solve this, we cube both sides, so let's just go ahead and let me just show you guys this to make it super clear for you guys. We cube both sides so that the left hand side is 1000, and then the right hand side is 6k plus 8, and then minus 8 on both sides, and then k is equal to, why did I make the number so big? I don't know why. But like it's 992 divided by 6. Can we reduce? Yeah, by 2. We get 496 over 3. Yeah, should be like this, right? All right, and then if you put that back here, you get y of t is equal to the cube root of, put that there, so we get 3 times the k is that, which is 496 over 3, and then the t, and then plus 8. And of course, this and that cancel. And in the end, we just have to figure out y of 4. So y of 4 is equal to the cube root of 496 times 4 plus 8. Yeah, and then you can use a calculator to figure that out. It's about 12 point something. Yeah, but like, yeah, just go ahead and figure it out. And then if you leave it in the exact form, then that's okay too. Yeah, but it's just arithmetic from here. But that's how you solve a differential equation for that. All right, pretty cool, huh? So far so good. Don't forget the D. Oh, you mean that, right? I believe. All right, cool. So we're done with that. I'm quite surprised we have almost 100 people. So thank you guys. Especially this is just a pretty new channel. We only have about like 6,000 subscribers. So yeah, that's a very good outcome. Thank you guys for coming. Let me know if you are taking a calculus class right now or not. All right, another differential equation. This right here will take some time. Number 12. Here, if you guys came here from my main channel because I make a post, here's the deal. All right, if you borrow, I'll just say, let me just write this down for you guys. If you borrow, let's say $30,000 to buy a house, and the mortgage rate, so I'll just say the rate, APR, annual percentage rate, is equal to 3% for 15 years. All right? So mortgage, how much is the monthly payment? That's quite interesting, and that's really important too. In fact, there's an absolute right way to do it with sequence and series and all that stuff, but we're not there yet. This is about differential equation. We can actually use a differential equation to solve this. So I will show you guys how to figure out the monthly payment. So what's the monthly payment? This is what we are trying to do, but when I write the test question, I put it down as a differential equation already because I want you to just solve the differential equation. But that differential equation is actually trying to solve this question. And the differential equation can give you an approximation. It's only off by $2, which is really, really good already. Hopefully, next time I will show you guys how to solve this kind of question with the sequence and series approach. So I just want to make that clear for you guys. So this is how we do it. First off, this is what we know. Right, this is like a compound interest formula, things like that. But if you look at the differential equation, let's say dA dt, meaning the rate of change of the amount that you owe. This right here is proportional, right? Proportional to the amount that you have. But in fact, we do know what that constant of proportionality is. It's about the interest rate. But this right here is annual interest rate. This is the monthly payment. So we have to make sure that the units agree. So for this right here, what we'll do is we just do 0. I shouldn't put down equal sign, I should put down an arrow. This can tell you the K, which is going to be 3% divided by 12. Work that out, you will get 0.0025. All right? Yeah, and that's exactly how I got that differential equation. And that's the K, I will put it down right here. We have 0.0025 times that. But you guys should know, this right here is just the exponential growth differential equation, right? That's no good, because this means that our debt is just going to keep growing forever. Don't worry, we are going to make the monthly payment. So to do that, we just have to minus M for monthly payment, and this right here can actually help us to figure this out. So this is the differential equation that we are going to use. And we also know that initially we owe that much because that's the amount of the money that we borrow. All right, so we have that. And I will just put this down right here just to save space. We want T so that A of 180 is equal to 0. Why 180? Because there are 180 months in 15 years. And in the end, we want to have the debt to be 0. So that's that. All right? So now let's just solve this differential equation. Remember, this is the entire right-hand side. We will have to divide this to left. So we get 1 over 0.0025 A minus M with the dA. And that's equal to multiply the dt here. And then we can integrate both sides, here and also here. This is the linear on the bottom, so we get ln, absolute value of that, 0.0025, A minus M, but divided by this number, which is 1 over, right, 0.0025, like this in the front. On the right-hand side, we get the integral of that, which is just K, and then that's add a C1. Okay, let's multiply everybody by that decimal, 0.0025. So that cancel, and we just get ln absolute value 0.0025 A minus M. This times, wait, it's not K, it should be T, sorry. So integrating this, we get T plus C1. This times that we get 0.0025 T and then plus, this times that's just C2, another constant, right? And then just continue. We do e to the power, we do e to the power, so that this and that cancel. And we see that we have the absolute value of 0.0025 a minus m. E to this power stays because that's the function part. So we have e to the 0.0025 t. We multiply by e to the c2. E is a constant, c2 is a constant. So this to that is just another constant. So let's put down c3. And now we are going to get rid of the absolute value. Literally get rid of that, put a plus minus. Positive c3 is a constant, negative c3 is a constant. So together, we can relabel this as c4. And then I'm going to just move this to the other side. So we have 0.0025 a, that's equal to m, and that's c4. And then we have e to the 0.0025 t. Whew. And then in the end, I'm going to divide everybody by 0.0025 so that this and that cancel. And then divide this by 0.0025 and divide this by 0.0025. So ladies and gentlemen, wow. A as a function of time is equal to, do this on your calculator or whatever, 1 over that is 400. So you have 400m. And then C4 divided by that is just another constant. So we label that as C5. But this is pretty much it. So we don't need the subscript anymore. So just C. And then we do have the function part, which is e to the 0.0025 t. So that would be the differential equation. Okay, initial condition. We know a of 0 is equal to 300,000. That's equal to 400m. That's equal to 400. Wait, we don't want t, we want m, sorry. We know t already, we want m. Yeah, but anyway. So we have 400m right here. T is 0, so we have just plus c e 0.0025 times 0 here. So this is just 1. So that means this is equal to this plus c. So I will tell you c is equal to, bring this to the other side. So we have 300,000 minus 400m. It's just a lot of algebra, right? Yeah, it's just a lot of algebra. So we want m, and then this is what we have. C is in terms of m. That's pretty good because now we can put this back to here, and then we also want this to happen. You see, we also want this to happen. So I'm going to have a of 180. We know this right here, we want it to be 0, and then the equation is this. We have 400m plus the c, which is this, right? The c is here, which is just going to be here. So I'm just going to write down. I am going to run out of space. I am going to run out of space. That's not fun. I'm just going to write it down like this because otherwise I'll run out of space. This is the c, okay? Times e to the 0.0025. And then the t is 180. Wow. Wrong color. It's not calculus anymore. It's just algebra. 180 divided by 400. What do you mean? I am actually just going to use decimal because right here, you just compute this on the calculator, you will get 1.5683. All right? And then you take this, multiply this, and you take that, multiply with that. So you get 0 is equal to, here we have 400m. And then you take this, multiply by that, you get, right? So again, you take this, multiply with that, you get 470,490, and then you take this, multiply that by that, you get minus 627.32 m. Combine like terms and all the good stuff, move this to the other side, so we get negative 470,490 equals this and that together, we get negative 227.32 m. So ladies and gentlemen, after you solve this differential equation, m is approximately 2069.73. So this right here is the answer for that. This right here is the answer for that. Okay, so here's the thing. If you use the online calculator, if you, how should I say? I always forgot about the name. I also forget about the name of this calculator. But the actual answer for this situation, if you're just talking about this situation, is $2,071.74. So this is actually the monthly payment that you have to make if this is indeed the situation. But as I said, on the test, I asked the students to solve this differential equation. So this is the answer with that differential equation. And as you can see, it's just off by about $2. We'll see how to get this answer hopefully next time. If not, I will make another video on this because this is super interesting. And this is how you calculate the monthly mortgage for this. So take a look. So for this one, it's still different. This is just differential equation, but like the application of it, and yeah. All right, last question. Oh my God. I think this is the longest question on the test. And it's a lot of algebra, that's all. And we'll have about 10 more minutes. That should give us enough time to do the next question. Oh, right. Here we go. Number 13. Let's consider an improper integral, which is the integral going from 1 to 3, e to the negative x to the third power dx. The question is, how large should n be so that the approximation when you use the midpoint rule is accurate within 0.0005. Alright, so that's the question. And whenever the question is asking how large should n be, or it deals with the error bound, right? Just of course the error bound formula. So let me write that down for you guys. This is what we are going to use right here. The error bound formula says the absolute value of the error when you use the midpoint rule. This right here is less than or equal to. Here we have k times b minus a raised to the third power divided by 24n squared. Well, what is k? K is going to be the maximum value of the absolute value of the second derivative of this. So we are going to find out k on the side here. Check this out. So let's say our function is that, which is e to the negative x to the third power. Go ahead and do the first derivative. So f prime of x. Well, we just have e to the negative x to the third power, and then you know the deal. Use the chain rule, of course. So multiply by the derivative right here, which is negative 3x squared. But to get the k, we need a second derivative. So let's do it again. And now we need the product rule as well. So f double prime. So keep the first function, negative 3x squared times the derivative of the second, which is e negative 3x, and then multiply by the derivative right here, which is negative 3x squared. Wrong color. And then we add the second function times the derivative of the first, which is negative 6x. I'm going to simplify this a little bit. I can factor this out. So this is e to the negative x to the third power. And then this times that is 9x to the fourth power minus 6x. So that's the second derivative. And then, this is not, by the way, this is not a bell-shaped curve. Bell-shaped curve is the negative x squared. But anyway. And then we are going to put this in the absolute value. And we're going to put this in the absolute value and then just graph it. And for my class, I let the students use graphing calculator to find the maximum because otherwise it's going to be rather bizarre. It's still possible to find the maximum, but like we'll just use a graphing calculator for this, and I will just give you guys the graph. So if you graph this, the picture is going to look like the following. It's going to look like this and then like that. Right? Somewhat like this. So that's the absolute value of the second derivative. And I will tell you, this point right here is what we care about because it goes from 1, right? This right here is actually 1. And then somewhere here is 3. So just care about from 1 to 3. So that's why we look at this, not that. This right here has the coordinate. The x is 1.2346. But we don't want x. We want the y. The y will give you the k value. And that will be 2.0565. And this is the k value that we are going to use. And if you round whatever at the end, I don't really mind, but like that's what you should be getting. So I will just denote that this is, we'll use this for the k. Yeah. All right. So now, this is the error bound formula. This is what the k is. So just plug in here. So we have 2.0565. And then the integral is going from a to b. So just plug in. So we have 3 minus 1 to the third power over 24. And we don't know yet. So square that. And we want this to be less than or equal to, because it says within. We want this to be less than or equal to that, which is 0.005. Oh, one more zero. Yeah. And then the easy way to do it is multiply both sides by n squared and divide this on both sides. So we really just get 2.0565, and that's just, of course, 2 to the third power and just 8, of course. But like 24, and then multiply by this on the bottom, which is 0.00. Miss this again. 0.05. And we want this to be less than or equal to n squared. Of course, everything is positive, that we just care about that. So we just take the square root on both sides, care about the positive only. And we will get n is greater than or equal to, if you entered all that on the calculator, you'll get about 37.027. But n is supposed to be a whole number because you're talking about the number of rectangles. And you always round up to just make sure that it's guaranteed to have this error or less. So just say, in words, n should be at least 38. All right. Whew. Done. That's it. All right. That's it. Took a while for the differential equation, also some parts, but we finished and have about a couple minutes. If you want to have a really challenging question, you can try to figure out number 14. I know it's a little bit too small. So ladies and gentlemen, take a look at this one. Yeah. So go ahead and do this if you would like. Yeah. I will make a video on the first derivative of this function though, but not the third derivative. But anyway, that's it for today. Thanks so much for coming. I'll answer some questions. How to get the k. All right, so k, let me just put this down right here. K is the maximum of the absolute value of the second derivative. K is the maximum of the absolute value of the second derivative. And we just care about on the interval a to b. And the way that I let the students do it is, of course, you have to do the derivative twice and just put the absolute value and then graph that and use the graphing calculator. You'll see this kind of picture. And this is the point of our interest, the highest point. because it's going from 1 to 3. So not this, but this. And then use the calculator function, you can find the maximum. You have the x value is this, and then the y value is that, and this right here is the k. So that will be how to find the k. And that's the only part that requires a calculus. All right. Okay, any other quick questions? Maybe just maybe another one. If you guys have any questions, just go ahead and ask. Too much writing shortcuts. Feels like math begins to be like physics. I didn't really write a lot of shortcuts, did I? But anyway, thank you guys so much for coming. I will see you guys next time when I do my exam number 3. Exam number 3 will be sequence and series. So if you're taking Cal 2 as well, you know, that's going to be perhaps the hardest part that people will tell you. So definitely come by and then we'll do them together. All right, as always, that's it. Bye, everybody.